Okay guys, this is a continuation of slope. This is a if you need extended practice setup. It says in some cases it is not always easy to find the y-intercept on the graph of a line. In previous lessons you were able to identify the y-intercept by looking at the graph or table of a linear relationship. Today you will learn a way to identify the y-intercept by using another method. In order to find the y-intercept of a line, you must know the slope of a line. So on this particular handout, if you guys want this, there's some good information. If not, I would suggest to get your notebooks and put this in there. We have written down what slope is numerous times, but slope is the vertical change divided by the horizontal change, or the change in y, remember our little triangle delta symbol, over the change in x. When we are given the two coordinates of, 2 points, you can find the slope with the slope formula, which is we determine our points, label them x1, y1, x2, y2, and use the change in y over the change in x, or y2 minus y1 divided by x2 minus x1. All of these are important information. If you're going to write them down or create your own little foldable for them, just pause the video or locate your notes from day 4. So to find the slope that passes through two given points and to determine if the line is a function, what we want to use is our y2 minus y1 over x2 minus x1. And then we want to consider this word. How do we know if it is a function? Well, to determine if a line is a function, it has to pass the vertical line test, meaning that it has to have a slope. It cannot be undefined. So we're going to start by labeling our points. X1, that should be a Y, sorry guys, my marker. X1, Y1, X2, Y2. Plug these in. Y2 is -1 minus 5 divided by 10 minus 7. -1 and -5 are same signs, so we're going to same sign, add and keep. That's going to give us a -6 divided by 10 minus 7 is a +3, which is equal to -2 divided by 1, or -2. At this particular point in time, we do have a slope, and therefore this will be a linear graph, and it will be a function. If you're confused what I'm talking about, whether it will be a function or not, by determining the slope, we will be sure and discuss that as we get through these following examples, because there will be a few that are not functions. So now let's continue on to number 2. I'm going to go ahead and just set it up without labeling them. So if you want to label them, you can label them yourself. So we have y2 is 4 minus -2 divided by 3 minus 3. Negative minus a negative, we want to turn into a positive. 4 plus 2, 6. 3 minus 3 is 0. When it comes to dividing anything by 0, we cannot actually do that. That's undefined. So another thing for us to consider is way back at the beginning of the year, we talked about if you have repeating x's, the line cannot be a function. So we could have looked at these 2 points and determined already that based off of the x values, this is an undefined graph, and therefore it is not a function. Proceeding on to number 3, we have 6 minus 8 divided by 8 minus a -2 minus a negative turns to plus. 6 minus 8 is going to be -2 divided by 10. Remember guys, if you're having trouble with the simple addition and or subtraction, you would like to use a calculator. We'll simplify this. 2 will go into both of them and we'll get negative 1 over 5 as the slope. Now if we look at our next one, number 4, we have repeating y values. We know that we cannot have repeating x values, but we want to go ahead and work this out and see if we can have repeating y values. So we're going to do 9 minus 9 over 11 minus 7. 9 minus 9 is 0 over 11 minus 7 is 9. So if we divided 0 by 9 in the calculator, we would get that it is equal to 0. We can have a slope of 0. That means that that's going to be one easy line to walk. Your legs aren't going to hurt after you walk up it, and it's going to be a horizontal line. Therefore, we do have a function. And I forgot to label here. Number 3 is a function as well. Okay, the following formulas can be used to find the equation of the line. Slope-intercept form is what we have been very, very familiar with. We've been using this for approximately maybe a month or so. The one that we actually have not seen this year is the point slope form. And for some of you, that's kind of been a struggle when it comes to one of the assignments that we were working on yesterday. So this is really important for you to consider the point slope form, and that's what we're going to be talking about today. So the slope of a line is 2, and it passes through the point 4 and 6. We know that we want to use the slope-intercept form when we have a table or we know slope and y-intercept. When we want to use point slope formulas when we are giving a slope and a point. So when we look at this one, we are given a slope and we are given a point. So we want to plug that in. So we have y minus y1. Our y1 would be 6. Y minus 6 is equal to, our slope is 2 times x minus x1, which is 4. So now this looks like it is not, like we can't graph this yet, so we want to go ahead and complete what we know using PEMDAS and our properties. So we're going to distribute the 2 throughout the parentheses, and we're going to get y minus 6 is equal to 2x minus 8. And like we've done numerous times before, we want to get y alone. So to do that, we have to figure out what we need to undo or what's going on next to our y. And for us, we have negative 6 over here, so we're going to do the opposite, and we're going to add 6 to both sides. When I add 6 to both sides, I have to find a like term. I cannot add 6 to the 2x, so I'm going to add it to the 8. And we'll get y equals 2x minus 2. And now we have it back in the form that we like really well. Number 6, the slope of a line is 1/2 and passes through the point negative 2, 3. So we're going to go ahead and just use the same thing. And what we're going to do is we're going to have y minus y1 is equal to the slope times x minus x1. And just this time we're going to plug it in. We're not even going to solve it all the way for a y. So when we look at this, our y1 is right here, and our x1 is right here. So once we plug that in, we're going to get y minus 3 is equal to the slope times, I said slope but didn't put it in. Our slope is 1/2, so it's equal to 1/2 times x minus negative 2. Now just for the sake, we're going to simplify it. Y minus 3 is equal to 1/2 of x plus 2. And we have it in point slope form, and we're going to leave it just where we've got it. We don't even need to worry about anything else. So using point slope form, we're going to go ahead and we're going to use the knowledge that we have to find the slope. Y2 minus y1 over x2 minus x1, and then we're going to plug it into the point slope formula. So this kind of breaks it down step by step. Y2 is 1 minus 5 over 4 minus 3. So our slope, m, is equal to negative 4 over 1, which is the same thing as negative 4. And now I have 2 points. I don't just have 1 point. And so we want to choose whichever one you want to use. It will end up the same. So I'm going to choose the first one and plug that in. So I'm going to have y minus y1, which was 5, is equal to negative 4 times x minus 3. And actually I told you wrong. We need to choose the first one because the formula itself tells us to use x1 and y1. And that way we don't start getting confused with our variables and we remember which one is labeled as which. So solving this, we're going to get y minus 5 is equal to negative 4x plus 12. We're going to add 5 to both sides and get y is equal to negative 4x plus 18. We can plug it into our calculator from here. I'm going to leave one for you to do so that we have some time to do the others because I know this video is starting to get very long. So at noon, the temperature of Way Too Cold USA is 12 degrees Fahrenheit. For the next 24 hours, the temperature fell by an average of 3 degrees Fahrenheit per hour. That's something we've talked about. Per hour means that we're going to multiply, and I'm going to just use the variable h. And then it says to write the equation for the temperature T in hours. Okay, well now the information has provided me with what I need to use. So I'm going to change that to in. So we also need to go through and look at what was important to us. So it says at noon, the temperature was 12 degrees Fahrenheit. Our question is saying after noon, and then it proceeds to tell us that it falls. When we fall, we're going to subtract by an average of 3 degrees Fahrenheit per hour. So we now know that we have temperature, which is our total, because that's what it's asking us for, is equal to the Fahrenheit at noon, so that's 12, and it's going to go down after noon, and it's subtracting 3 per hour, and so our per hour tells us to do 3n. When we look at this, we have arrived at our equation that we're going to use for the next couple. And it says, what is the y-intercept of the equation and what does it tell you about the situation? Well, we need to go back and write what we know about linear equations. Y equals mx plus b, and b is the y-intercept. So when we look back at this equation, we want to find the constant, or the number that does not have a variable for us. That would be 12. And what it means in this particular situation is it tells us what the temperature started at Way Too Cold USA. So we're going to do 12 degrees Fahrenheit is the temperature. And you guys need to use full sentences if you're doing this for a homework. Stop it. Okay, so we find the temperature is our b value, and now the 11 asks for the slope of the equation. Well, that's the number in front of our variable. So for us, that is going to be negative 3. And negative 3 tells us what it's changing by each hour. It's going to change by minus 3 degrees each hour. Okay, so for the last question, we just plugged in the hour that they gave us and solved it and came to the conclusion that t equals negative 9. You want to look through this work a little bit and see if it's the same as yours.